Welcome and thanks for joining us. My guest today is Gary Hicks. He's the Chief Technology Officer for Hitachi Vantara Federal. Gary, good to have you with us this morning.
No, thanks for having me, Tom.
And of course, artificial intelligence is on every agency's lips. It's on everybody's lips. In fact, I just read a study this morning that showed that just the Chinese large universities have published almost 30,000 papers on artificial intelligence in the past year. So everybody is pursuing artificial intelligence, but real production, industrial application success in artificial intelligence has a lot to do with the data that you put together before you even start to deploy an algorithm. So maybe just frame in the beginning, what is the data requirement and how data needs to be thought about by practitioners getting into this whole AI and ML zone?
Yeah, I think it's a key point that data is at the core of it, and I think one of the things that I'm starting to see, and I think we've seen in others, is that data set is still relatively small in regards to all the data that's available. People have just started within the last couple years really curating data, I think, and really kind of capturing that data. Because before, if we would use the data and then we would print it out, delete it, and whatever, and that used to be the message probably 10 years ago, is like, purge your data. You don't need to keep everything. Now we've gone the other end of the spectrum where, hey, keep everything. It's important. It may better your model, and you want to have as much data in that lake as you possibly can.
Of course, the issue there too is that data is a growing phenomenon. It's
hmm
accelerating. I mean, you don't see any slowdown in the growth of data, do you?
No. I mean, with all the sensors that are, everything is connected now. Your refrigerator, your smart devices, everything creates data, and it creates a huge amount. We have high-speed trains that actually have thousands of sensors that creates 3 terabytes of data a day. So if you think of that over multiple trains, it's just continuing to kind of snowball and grow. Um, and a lot of people, when they look at the data, you want to keep it because you're not sure how it's going to apply to your model. So you don't want to throw it away before you've determined that, hey, it really has no value in my model, or it's not going to better inform that. So no, it's definitely not slowing down. And especially, like I said, as we continue to save it, it becomes even more important, because that metadata around that data, it's the data itself is important, but the characteristics and how that data was created, what does it mean to everything else, is also a key component of that.
Yes, there, and the idea there is that you have to train your algorithms with the correct data, not just any data. Otherwise, you
Correct.
won't get the results you're hoping for, or you'll get results that are perfect but biased to some degree for whatever
hmm
you don't want to have in your outcomes for your AI and your ML.
Yeah. It's kind of having that base set of accurate data, and making sure that you're not flawing the algorithm. And then you take it, once you train it, you take it and try to apply it and find out, how good was your test data set? Is it, well, maybe there was a flaw in it, maybe there was a flaw in the algorithm or the way that you approached it. Because that's one of the big things that people are afraid of, is introducing that bias into that, and that test data and that core data set that you're working with is obviously a key component of that.
And when you look across federal agencies, what do you see as their data practices that they probably could stand improving on? Again, pursuant to both efficient handling of the data, but also success in training their systems.
So I think there's a lot of I think they're really looking at it, and there's a lot of different artificial intelligence centers and centers of excellence that are popping up, and I think it's kind of the natural maturation of what they were doing with big data challenges, things of that nature. So now, as they've continued to go into that, they're actually consolidating that data and pulling it together, pulling it out of these different various silos. I think they're doing a better job at that, as well. But there's still challenge with that, because there's pockets of data everywhere. So, as and between, interagency sharing as well, because a lot of the data that, somebody like NOAA or somebody may create is key to the Department of Energy or the DoD. So I think data sharing is an area that they can get much better with. But a lot of that comes along with kind of building these data taxonomies as well. And there's no kind of overarching standard. Everyone has, based on their use case or their industry, has their own type of approach to what is that data taxonomy.
Right. So if I'm the Marine Mammal Commission and I'm working in one sense with fish and wildlife, and on the other hand with NOAA, I may be, gathering data that has different taxonomies and was gathered for different purposes, and I need it for a third purpose. That's one of the challenges.
Correct, and being able to extrapolate certain data sets, because you if you're doing marine mammal, you don't need all that data. You may only need a certain segment of it. So being able to carve out that data set and move it and manipulate it and ingest it, and store it is the way that most people are going to approach it. This concept of this huge federated data cloud is something that would be such a massive undertaking. So I think you're still going to see people challenged with data access issues, and keeping consistency of that data as well, the accuracy as you move it around, manipulate it.
Yeah, that's always the tension, I guess, almost since the beginning of computing, or as we know it with online computing, is do you build one big giant instance of a data lake or a data warehouse, they called it a number of years ago, versus
Yep.
just simply having a logical data warehouse, even though the data might be stored disparately. Both sides have advantages and disadvantages.
Yeah, it's having, I mean, at the end of the day, it comes down to data access and management. There's not going to be one system to rule them all. If you think back, way back, we used to all have mainframes that everything was centrally located, everything was on that mainframe in that company. But now we've gone to the point where if you take kind of play that forward, everyone has a mainframe, but we want them all to talk to each other. So building kind of that Uber, I mean, and the size of the data that you would have to manipulate and work with just becomes, exponentially challenging. Even if you could get everyone to agree, the scale of it would be challenging. But having kind of consistent data taxonomies and standards in place would be something that would be good to come. And we've had some of that with, standardized metadata tagging. APIs help a lot. So I think it's just continuing to kind of develop and go down that road. But I think that's a long-term challenge.
So, what is a good approach then for specifically AI and ML training when you don't need all the data in the world, but you still want to have a data source that you can enrich if need be to further the training and more refine what it is your process is trying to produce for you?
Yeah, I think it's there's kind of two pieces to it. There's data access, and then there's data performance. Because one of the things that we've seen with AI ML is heritage kind of legacy file-based solutions, because most of this is unstructured data at the end of the day. File-based solutions fall down from a performance perspective and a data sharing perspective. You need something that has kind of a global parallel data access methodology as part of this. And then also provide the speed of that, because in the past we would just copy data around. We don't want to do that today. We want something that I can host one kind of unified namespace and everyone can access that, and it takes care of data locking. It ensures data integrity, consistency as well.
So specifically, then you should not copy data from a source and then put it in another like dedicated data lake for AI training. That's something you should avoid doing.
I think it's something. I mean, you can pull it out, but you want to make sure the integrity of your production AI data. Everyone kind of has test data, and even with data warehouses, we used to do that with data marts where we would pull it out. So it's you still need kind of that consistent core data repository and the lake, if you will, that you have to manipulate for your production data. But you can pull it out in a read-only mode, if you think of it in that sense, to manipulate and work with that data. But you still need that global kind of unified namespace that you're going to work with, where you can co-locate that data and provide efficient data access.
And we mentioned NOAA, and I'll just cite them as one of several federal agencies that have high performance computing clusters, complexes with supercomputing. And they do a lot of production work to get products out, for Weather Service or whatever the case might be, that energy labs have similar types of things. Plus, they also do analysis. And so, is there any lessons learned from the way the high performance domain handles data and uses it for perhaps more than one purpose?
Yeah, I think they're very good data historians, if you will, because if you look at NOAA, you go down and look at their data sets. I mean, they have petabytes or even exabytes of tape out there with that historical data that they're leveraging. I think that's historically where you saw kind of HPC environments. They're like they were used to dealing with data. And I think with the advent of public cloud technologies and longer, larger data stores, it kind of we have the ability as to extend that beyond the HPC environment. Now you don't have to go buy a huge Cray supercomputer or an NVIDIA, you know, supercomputer with tons of GPUs. You can go out to Amazon, Azure, Google, wherever it may be, Hitachi, and buy that type of infrastructure that you can host very quickly and kind of spin it up. So I think the advent of public cloud has made it more accessible to somebody that couldn't afford a Cray supercomputer, but their data management practices have informed kind of this entire AI ML data management.
So a lot of then that whole training and management issue can take place in the cloud, almost contained within that cloud.
Yeah, absolutely, and I think it allows them the elasticity to expand, bring it down, but the data is going to stay there. And most solutions, most of our training and what we look at is focused on the metadata. It's not necessarily the in data, the image or the object, whatever it may be. So keeping that as close. So a lot of times what you'll see is they'll host data in the cloud, but they'll keep all that metadata closer to the compute on the private on-prem, wherever it may be.
My guest today is Gary Hicks, the Chief Technology Officer of Hitachi Vantara Federal. I'm Tom Temin. This discussion is how to best leverage your data for AI and ML, sponsored by Hitachi Vantara Federal here on Federal News Network.